Hey folks, it's Michael Johnson. Welcome to the Energy Sketch. We're going to talk a little bit about renewable natural gas today. This was in the news in Quebec recently. There was a bit of a hubbub around Énergir, which is our natural gas supplier. And I happened to see this billboard in the subway, and it brought up a few questions and interesting threads for me, so we're going to get into it. What bothers me about this billboard, honestly, is this sort of, again, focusing somehow on individual action. And the sort of message that I get from here is like, if only everybody composted their banana peels, we could power civilization with the renewable natural gas that's produced. And so today we'll go into a few numbers and ideas around there to ask the question, does it scale? Here we go. Let's get into it, folks. Thanks for being here on the Energy Sketch. So here's a little mind map of some of the concepts that I want to touch on around the concept of renewable natural gas. So the first thing is this publicity that I just shared about, and these are the plans that Énergir offers. So you can choose to pay more on your natural gas bill in order to encourage production of biogas, because currently only about 1% of the natural gas that flows through Énergir's gas grid is made from renewable sources. So you can choose to pay more on your natural gas bill. You can commit to providing 10% of your personal consumption for an extra $5 a month, or commit to an active profile at 30% renewable natural gas for your consumption at $15 a month, or be fully committed and pay equivalently for 100% of your supply to come from renewable natural gas at $45 a month. What comes up for me here is, again, this sort of focusing on individual actions versus collective actions. So we're kind of relying on people who can afford it to pay more voluntarily for their natural gas in order to feel good, in order to encourage production of renewable natural gas, instead of collectively bringing in laws, rules, legislation, increased prices done in an equitable way that will collectively transition us in what I believe would be a much more effective manner. So that's this concept of individual versus collective action. Now, here on the bottom here, we have kind of like, who are the customers of the natural gas companies? That's residential. We use it for home heating. We use it for cooking. Also industrial. It's used for heating, commercial buildings. And what are the other options for decarbonizing those heating sources that we need? Electrifying them, heat pumps, geothermal, maybe other things like iron that I've mentioned before and will mention again. And then this idea that we're in this kind of mid-transition zone and natural gas is going down. People are converting to heat pumps to electric heat. New buildings are being built that are exclusively electric heat, maybe with a bit of backup. So there's this idea that in the future we'll need to prune parts of the natural gas grid, of the natural gas network, close some of them off because we won't be supplying those regions anymore with natural gas. And there's a lot of potential issues that come up there that I've talked a little bit about in a previous episode on gas stations, and we'll continue that discussion in future episodes. But today we're going to dig into a little bit of the production of this renewable natural gas. How is it produced? Typically from feedstocks like agricultural waste, food waste, livestock, manure, things like this. And there's a few other threads there of what other uses could those waste products be used for. And also, the entire supply chain really of agriculture is heavily fossil-based also. So how can we reduce that consumption going to more small-scale, organic farms, all those other threads there around our current food system. Ultimately, what I want to do is answer the question, renewable natural gas, does it scale? So these are the questions that we're going to get into here on the Energy Sketch. So here's our little banana peel in the middle here, and disclaimer at the bottom, all opinions are my own, everything is an estimate, no guarantees, no refunds. We're going to show some numbers here, and I'll put the references in the description of the video. So first, how is natural gas produced from this kitchen waste, from food waste? Well, we collect it individually in our brown bins, and trucks patrol the streets of Montreal and Quebec to gather up all of that food waste, and then it's brought to an anaerobic digester, sort of a plant that digests that waste without oxygen, and it produces two products, basically a solid byproduct that can be used as a fertilizer and a gaseous product that's called biogas. It's a mixture of methane and CO2, and what we do is we strip out the methane and do something else with the CO2, hopefully perhaps sequestering it or using it for some other purposes, and what we're left with is the methane, which we call renewable natural gas. And don't forget, upstream of this banana peel is an entire supply chain, right, with its own fuel consumption, its own carbon and methane emissions. That's from growing, harvesting, processing the food, refrigerating it, transporting it. These bananas come from Costa Rica. They got to get up to Quebec somehow. So let's not forget about that whole upstream supply chain and the importance also, of course, of decarbonizing the food supply chain. But let's get into the specifics here on, does the renewable natural gas from food waste scale? How much can we produce, really? Well, I got some statistics here. Links are in the description. In Canada, the average person wastes about 80 kilos of food per year. And from that food waste, for each ton of food waste, we can produce about 380 cubic meters of methane gas. So for each person in Canada, we could produce about 30 cubic meters of methane per person per year. That's a number. It's just a number. We have nothing to compare it against. So what we want to compare this against is the fossil methane consumption of the average Canadian. So compared to fossil methane consumption in Canada, which ranges between about 2,000 to 3,000 cubic meters per person per year, depending on where you are, how much heating you need in the winter, etc. So we're off by about a factor of 100. So compared to the average fossil methane consumption per person per year in Canada, the potential production of renewable natural gas is off by a factor of 100. So it really just doesn't scale. We are never going to power our civilization using banana peel waste transformed into natural gas. Not that it's not important to compost, to reduce kitchen waste, methane emissions, landfill, gas and liquids that harm the environment. These things are very important, but let's not kid ourselves. Let's not pretend that me composting that banana peel is going to enable me to heat my home with the renewable natural gas that's produced. It just does not scale. So those are my thoughts today on renewable natural gas, folks. What are your thoughts on this publicity? What comes up for you when you see that publicity? And what are your thoughts there on how we might decarbonize heating, food supply, all of those related issues? I'd love to hear from you in the comments and social media. So tune in Mondays, 12 p.m. on youtube.com/@EnergySketch. Thanks so much for tuning in, folks. Toodaloo!